Hey guys, in this video we're going to be talking about the motion of the planets. Now, not any planet in particular, just how you might see planets closer to the sun move relative to the Earth, and how planets farther away from the sun move. And so what this will allow you to do is it'll allow you to see why you can only see certain planets at certain times, or why they seem to disappear sometimes. And then we'll carry on with this idea in a future lesson, hopefully when we talk about the moon a little bit more. All right, so basically what we've got here is we've got the Earth. And so if you follow this circle, this middle one right here, this is Earth's orbit. All right? Earth's orbit. Okay? Any planets closer to the sun are known as inferior planets. Okay, it might sound like a little bit of an insulting name. And any planets farther out are known as superior planets. Okay, so this orbit right here could represent either of the inferior planets, Mercury or Venus. And then this big one out here could represent the orbit of any superior planet. So it could be Mars, Jupiter, Saturn, Uranus, or Neptune. All right? Now, there are a few different positions that I want to talk about here with the motion of the planets. So let's start with the inferior planets. If you look at, I'm going to have to get rid of this, but I'll put it sort of here, inferior. And superior is out there. So if you're looking at, from Earth right here, if you're looking at, let's say, Venus, and it's sitting right here, well, it's sitting right in front of the sun. Chances are, if the sun is up, you can't see Venus because the sun is too bright, and Venus isn't big enough to blot out the sun's light in any significant way that your eyes could detect. So you can't see Venus here. You also can't see Venus if it's all the way back here. And both of these positions have a name. These are called conjunction. Right? For anyone who's interested, superior conjunction is when it's on the opposite side of the sun. Inferior conjunction is on this side, but let it suffice to say that both of these are called conjunction. That's that one and this one right here. Conjunction. Okay, so both of those are conjunction. So basically when the planet and the sun meet up in the sky, they're not actually meeting up, it's staying the same distance from the sun, but from our perspective, the two are crossing paths. So that's called conjunction. Now this next one is a little bit more complicated. This special place right here, where the sun, the planet, let's say Venus, for example, and Earth, if you drew a triangle, that this angle right here is 90 degrees. Okay? This angle right here is 90 degrees. When this is the case, you're going to have to take my word on this one. When this is the case, when this angle right here is a right angle, then that's the farthest you're ever going to see that planet appear to be from the sun. Okay? Now, you might think that that should be over here, but if you draw a line from the Earth to over there, this angle from here to here is smaller than this angle from here to there. All right, so there's this special spot that's not at a 90-degree angle with the sun, but like from between the sun and the Earth and that planet. Don't make a 90-degree angle there. They make a 90-degree angle where from that planet, the sun and the Earth are 90 degrees apart in the sky. Okay, and that position, that might have been a very confusing explanation, I'm sorry. This position means that it's not that the planet looks like it's a quarter of the way around the sky from our perspective, that if the sun is over there in that direction, that the planet is going to be all the way over there in that direction. It means that it's going to be a little bit over to the one side, but that's as far as it's ever going to be. And we call that greatest elongation. Okay? Yes. All right, yeah, so this is greatest elongation right here. And so that's basically the farthest you'll ever see that planet from the sun. So if you notice, for Venus and Mercury, they just simply cannot be found on this side of the sky, because they have to be not that far from the sun. In the sky, they don't ever get that far. They're either a little bit this way or a little bit that way, but never any more than that. So if you're looking up at the night sky looking for Venus, you're not going to find it, because if it's night, you're on the wrong side of the Earth. You're on this side of the Earth looking for a planet that's somewhere over here. So that just doesn't help. Now with the two outer ones over here, or with the four outer ones, there's four outer points that are of interest. The first one is right down here. It's basically like our eclipse discussion, except we've got the Earth. So we've got the Earth in the middle, we've got an outer planet over here, and the sun in the middle of the whole solar system, of course. So Earth is in the middle of the system. You've got the sun, then the Earth, then the planet, and this is known as opposition. Okay, so what this means is that if it's midnight, the sun is, or at least the sun should be, as far away from you as possible, you standing on the surface where it's midnight, and that planet should be at its highest point in the sky, roughly. Similarly, at high noon, the sun is at its highest point, and that planet is at its lowest point, you could say. It's all the way on the opposite side of the planet. All right, so that's opposition. Both of these two special spots are where the Earth is in the middle of this 90-degree angle. I'm going to have to erase the word Earth and a little bit of the orbit. But basically you've got the sun, this line that connects the sun and the Earth, and this line that connects Earth and that planet, let's say Saturn, and that angle in between is 90 degrees, and it's the same on both sides. This is known as quadrature. Quadrature over there, and quadrature over there. All right, both of them. So that's called quadrature. So we've got opposition there, quadrature on both sides. So basically you've got the sun, let's say over there, and you have to rotate 90 degrees to see the planet in the sky. All right, so it may be at sunset. The sun is basically, flat ahead, so the planet could be at its highest point then. All right, and the last one is all the way up here when the planet goes behind the sun, and it looks from our perspective like it's meeting up with the sun, and this is called opposition. No, this is called conjunction. So just like we had with inferior planets, conjunction is when the planet and the sun, from our perspective, appear to cross paths in the sky. All right, so these are sort of the 8 key points for planets' motion in the solar system. 4 key points for the inner solar system, 2 for conjunction, and 2 for greatest elongation, here and here. And then for the outer planets, we've got opposition on this side, conjunction on the opposite side, and then quadrature in the middle. All right, we can continue this idea if we scale down from the solar system to the scale of just the moon, the Earth-Moon system. So let's ignore the sun. We'll just indicate the direction the sun is. So we'll say the sun is somewhere in that direction off the whiteboard. And we've got the Earth here and the orbit of the moon around the Earth. All right, so if the sun is all the way in that direction, if the moon is sitting right here, then from your perspective, standing on the surface of Earth, you don't see any of the half of the moon that is brightly lit. You see the half that's in its own shadow. And so to us, we call this a new moon. Okay, this is called a new moon. So you don't see any light coming off the moon. It's in the same direction in the sky as the sun is, so you generally struggle to see it until kind of the next night or the night after that. On the opposite side, over here, you don't see any portion of the moon that isn't lit, that isn't illuminated. So from your perspective, standing here now, you see a full brightly lit circle, and obviously we call this a full moon. Alright, now we've got a whole bunch of things in the middle that we have to figure out. Okay, so we've got the next logical points to consider would be when it's sort of halfway in between. Okay, so when it's halfway in between, you see that one half of the moon is illuminated and the other half is not. Okay, so for a new moon, your picture of the moon, if you were to take a picture of it, you'd see a completely black circle. Okay, and for a full moon, if you took a picture of it, you'll see a completely white circle, a fully lit picture. Okay, now if you look at this one in the middle, you look up and you see that the right half of it is lit and the left half of it is dark. Okay, and on the opposite side, you've got the left half of it is lit and the right half of it is dark. Okay, so these two are flipped. Now, if the moon is going around the Earth in this direction, then you will see this one first. And so we call this one first quarter. And then it proceeds from new moon to first quarter to full moon, over here to last quarter. Okay, but the moon doesn't always look half lit, fully lit, or completely dark. Most of the time, you'll see it in one of the intermediate positions inside that. So it could be here, for instance. And if you're standing on the Earth right here and you look up, you'll see something that looks like this, where only the right portion of the moon is lit. And this is called a waxing crescent. Okay, so you go from new moon and then you go in this direction to waxing crescent. Waxing just means that it's growing, that it's going from completely dark and it's getting more and more lit. All right, so you go from new moon to waxing crescent to first quarter. Then if it goes down here, you'll see more than half of it lit, but not fully. You'll see sort of 2/3 or 3/4 of it lit, something like that. And this is called a waxing gibbous. Okay, so we go from new moon to waxing crescent to first quarter to waxing gibbous to a full moon. Now you can hopefully see where this is going. On the other side, you look up at the moon. I didn't draw in our person. You look up at the moon and you see the same thing as a waxing gibbous, but now on the other side. So instead of the left half being dark, or the left portion being dark, the right portion is dark. And this is called a waning gibbous. Alright, so you go from new moon, first quarter, new moon waxing crescent to first quarter to waxing gibbous to a full moon. So this entire process, more and more and more of the surface of the moon is being illuminated from your point of view. Now you start going in the other direction. Waning means that the amount of light on the surface of the moon is decreasing. So you go from a full moon to a waning gibbous to last quarter. And I think you can see where this is going. The last one is going to be, well, waning because it's getting smaller. And if you simply look at the shape of it, just the left-hand portion is illuminated and the rest of it is dark. And this is called a waning crescent. Okay, so that's the whole order. You go from a new moon, which looks like this, we'll number that 1, to waxing crescent, number 2, over here to first quarter, number 3, waxing gibbous, number 4, full moon, number 5, waning gibbous, number 6, last quarter, number 7, and waning crescent, number 8. And then the cycle repeats itself. So anywhere between last quarter and new moon, it'll be waning crescent. So for all of these intermediate ones, new moon, first quarter, full moon, and last quarter all last for like a day, less than a day. So it'll be a specific day on your calendar. You might see new moon or first quarter or last quarter or full moon on your calendar. But the rest of the days in between, like in between new moon and first quarter, all of those days in between, the moon is in the phase of waxing crescent. All right, now if the moon takes about 28 days, 4 weeks to go around, then going from new moon right here to first quarter, well, that's a quarter of its journey. So out of 4 weeks, 1 quarter of 4 weeks is 1 week. So the time frame between new moon and first quarter should be about 7 days. It might be 6 sometimes or 8 other times, but it's about 7 days. So it's about a 7-day interval between new moon and first quarter, between first quarter and full moon, between full moon and last quarter, and between last quarter and new moon. So you'll have about a week's worth of each of these intermediate ones in the middle. All right, hopefully that's all making sense and you're able to get that diagram copied out. There probably will be some question on your exam about this if I can just figure out how to get the pictures on the exam without using a lot of ink. So I'll figure that out, but make sure you study this because there's a lot that I could ask on this. All right, if you have any questions, either let your teacher know or leave a comment if you guys have a YouTube account. Otherwise, I'll see you in the next video.